Hey guys, what's going on? Wayne here. So look, a couple of weeks ago, we were at MINExpo 2021 in Las Vegas. And, I think when I look back on this show in about 10 years, it's going to be a memorable one because of really two specific product introductions we saw at that show. Now, the first we've already covered here on FCP. If you haven't seen our video coverage of the R1700XE underground loader that Caterpillar unveiled at its MINExpo booth, be sure to check that one out. That's a battery-powered mining loader that can be charged up in just 20 minutes by a mobile battery pack. But the second, equally important and potentially even more disruptive announcement came from the Komatsu booth. Well, it was there in spirit anyway. This is the MC51. Well, this is video of a video of the MC51 that Komatsu featured in a very cool kind of facsimile complete with this foam rock structure at the booth. This machine is still very much in testing and development. There's really only two in existence and both of those are at work, so they couldn't bring them to the show. Komatsu is calling this a continuous mining machine and it's designed to completely disrupt the traditional hard rock underground mining cycle. Yes, it's a groundbreaking machine. Just see what I did there? Groundbreaking. Okay, anyway. This is a groundbreaking machine more than 10 years in the making. And there's really three reasons that Komatsu has created this machine: consolidation, control, and cost. Consolidation because the MC51 allows you to do what traditionally requires three different processes and machines with just one machine. Control because it operates nearly autonomously. And then there's cost because the consolidation and the control aspects that we mentioned earlier, combined with the fact that the MC51 requires less power to operate and lower ventilation costs just due to the way that it operates underground, those things amount to greater efficiency in both power and production.
It really takes today what is a batch mining process and starts to drive it into a more continuous process to help improve safety and productivity for our customers.
But let's get into specifics. What is it about the MC51 that allows it to replace traditional established machines like a jumbo? At a core level, the MC51 approaches rock removal in a fundamentally different way than traditional mining methods or even tunnel boring machines. Whereas both of those techniques involve drilling, the jumbo drills holes for dynamite to be placed in, for instance, the MC51 cuts the rock away through the use of a cutting head. So the difference there is that instead of using compression like you do whenever you drill something, compressing and pushing into the surface, the MC51 is based around removal with intent. It's all about placing that drilling head where you don't want rock to be and simply erasing it. Now, the machine does this by spinning that cutting head at a really high rate of speed and then placing it against the rock face at a 45-degree angle. That essentially allows the cutting head to get behind the layer of rock that it needs to remove and then pull the material away from the face.
It will actually attack the rock at an angle and it will come in behind the rock. And the cutting head, it rotates and it oscillates. And what it's doing is it's actually pulling that rock off the face to reduce the amount of energy we have to put into the overall process.
So again, let me stress, this is a completely different approach to removing rock, right? You've got compression, which is pushing into the rock. This is actually getting behind the rock and pulling it away, a completely different approach to rock removal. And not just from the drilling perspective, right? Dynamite removes rock through compression as well. I mean, the dynamite explodes from within the hole you drill in the rock. It creates a highly compressed kind of force that then expands and then takes the rock with it.
Yeah, so the traditional mining cycle, usually we start by marking up the face, we drill the round. So we bring the jumbo in, we drill our holes. Those are then loaded with explosives, charged and detonated. After that, we obviously have to ventilate to clear out those gaseous fumes. And then we bring in an LHD or a combination of a loader and a truck to muck out the blasted rock. Then we bring in a means of ground support, typically a bolter, to secure the heading. And then we would paint the face and start over. So really the MC51 changes the way we think about the mining cycle and allows us to be smarter about things going forward, improving productivity and again, safety.
And the other kind of negative byproduct of removing rock with compression is that you can't consistently predict the size of the debris that is going to result from that type of removal. And in many situations, that can lead to overbreak and the extra cost of having to move rock that you didn't necessarily have to move in the first place. Overbreak is essentially eliminated by the MC51 because the cutting head's removal of the material is so controlled that not only does it produce consistent and much smaller shards shards of debris, it does so at the direction of a digital design plan. In other words, this machine only removes the rock you want it to, nothing more and nothing less. And though the cutting happens autonomously through loaded up digital plans, the machine is actually trammed into and out of position tele-remotely by an operator using a tethered control box. And here's the second aspect of how the MC51 consolidates the hard rock underground mining process. Because of that smaller rock debris coming off the face and the less overall tonnage of rock that now needs to be moved because you're eliminating overbreak, the MC51 can actually eliminate the mucking process that's typically performed by underground loaders. Now, right through the middle of the machine, you can actually see a conveyor system running. That conveyor system is fed by these two spinning, fan-like blades that pull in piles of the debris as it falls off the rock face. Now, the debris is then fed through that conveyor system and deposited, and at the other end, you can either have an underground loader, pick that material up and tram it to wherever it's going to be deposited. But Komatsu says that they're also working on kind of like a conveyor belt extender system that would extend that conveyor belt, all the way from the rock face where the cutting is happening to wherever the drift opening is. And we mentioned earlier the lower cost thanks to the lower ventilation demands and the lower power demands, and that's because the MC51 is fully electric. However, it's not battery powered. It requires a tethered connection to the grid. But Komatsu says that shouldn't be a problem, as most underground hard rock operations have substantial electrical infrastructure at the face of the rock. The other big aspect to why this machine doesn't require much power is that because of how precise it is and because it is, kind of relying on intent and efficiency and not pulverization, the machine actually draws and pulls less power. And on the ventilation aspect, the machine, because it's electric, it creates a lot less heat and it produces no fumes. Now, Komatsu has designed the MC51 for use in 5x5 meter drifts. And the reason they designed it for that size is that Komatsu says that is the most common development tunnel size that they see in the market today. And they've partnered with mining giant Vale to actually test two prototype machines in the real world. Now, obviously, kind of taking all of that in, there are some caveats. Drifts that are smaller than 5x5 won't be able to put this machine to use. And while the conveyor system sounds awesome, it's most likely not going to be replacing your underground loader for tramming material back and forth anytime soon. After all, it does sound like at some point in the process, you're still going to need a loader of some sort. But Komatsu's point is that it might not be an underground loader. Another machine integral to the hard rock underground mining process that the MC51 can't replace is the hard rock bolter. Once the MC51 is done doing its thing and removing the material, you're still going to need to move it out of the way and move in a bolter like Komatsu's new ZB21. Now, those little kind of downsides or caveats aside, the MC51 is a potentially very disruptive machine for the mining industry. Combining all of those processes, the lower cost, the greater efficiency, the lower demands on ventilation, getting operators actually out of the cab and kind of putting them, back in a safer area behind the machine with that kind of like tele-remote control. All of those things are going to appeal a lot to a lot of customers in the mining industry. The fact that Vale has signed on to put two of these things to use right off the bat shows there's a lot of potential here for this to really kind of change the way fundamentally that rock is removed within a drift. However, though Komatsu has been in development on the MC51 for more than a decade, it's not quite ready. And Komatsu isn't commenting on the potential release date or like a timeline for the release of this machine, and they only note that machines of this type serving the customers it's going to serve in the environments that it's going to serve in, those things require thorough validation. And that's something that they're confident that this partnership with Vale will provide. All right, guys, that's going to wrap it up for our preview look here at the Komatsu MC51, a potentially game-changing machine when it comes to hard rock underground mining. Thank you so much for watching. Thank you to the folks at Komatsu for helping us put this video together. Hey, if you're watching us on YouTube, be sure to subscribe to our channel. And if you haven't already, follow us on all of our social media channels. Thanks, guys. We'll see you next time.